So for our topic, in continuation about the physical properties of matter. So when we talk about physical, means to say the real objects or materials comes into place in which it is visible and it can be touched or it can be carried out. So what is really a physical change? Remember guys, there were few changes or components that we need to consider. How things react by means of chemical reactions, no, through chemical change, in which new substances are formed. That's basically for chemical change. When we talk about physical change, the real objects in which we also considered that whatever transformation or processes or any techniques in order to change the object, it will remain the same. Right? What is physical change? So physical changes, remember, in this concept, how can a change in energy affect the state of matter? What happens when something dissolves? And what is meant by conservation of mass? So, this is basically that we need to find out, no? In order to check what really physical change or a chemical change. First, what is physical change? Physical change, a change in the size, shape, form, or state of matter that does not change the matter's identity. Okay? So what does that mean? Like for example, we have there solid, the liquid, and gas. Those are the three states of matter that we all learned ever since when you were in elementary grade and now you are in high school. The three states of matter are solid, liquid, gas. Solid, liquid, gas. Right? So those three states of matter are present around us. And those things that usually visible, okay, we can physically touch. We can easily carry those things. Some of those may not be very visible, but it can be felt. Like air, carbon dioxide gas, or smoke, or the smell. Okay? So, in physical change, state of matter that does not change the matter's identity. Okay? For example, when you are going to cut or tear the papers into pieces, chopping or cutting of wood, breaking of glass. Okay? So, those are physical changes. Right? Then turning ice into liquid. Turning liquid into ice. So, it involves with changes of states of matter. Like solid to liquid. Liquid to solid. Okay? So, like for example, in freezing, turning liquid to solid. Then for melting, turning solid to liquid. Okay? So, those are part of what we call physical change or physical changes. A physical change is a change in size, shape, form, or state of matter in which the matter's identity stays the same. Huh? So for example, as I've said earlier, like breaking of wood, tearing of papers, breaking of glass, chopping of any, wood objects, or punching your tables. Okay? The object still the same. The original composition stay the same. That's physical change. Okay? So during physical change, the matter does not become something different, even though physical properties change. Again, guys, what do you call of a physical change of states of matter or phase of changes of matter? By turning solid to liquid. What is it? Turning solid into liquid. Freezing. Okay? Turning liquid to solid. Okay. Turning liquid to solid. Freezing, right? Turning liquid to solid. Turning liquid to solid. What is it? Turning liquid to solid. What is it? Okay, freezing. Turning solid to liquid. Melting. Okay. Turning liquid to gas. Evaporation. Turning liquid, into solid. Again. Liquid to solid. Okay. Turning gas to liquid. Condensation. Okay. So, again, turning gas to solid. Turning gas to solid. Deposition. Turning solid to gas. Turning solid to gas. Sublimation. Okay, I'll repeat. Turning gas to liquid. Turning gas to liquid. Okay, condensation. Turning gas to liquid. Turning gas to liquid. Okay, so liquid to gas, condensation. Gas to liquid. Gas to liquid. That will be evaporation, right? Okay, continue. When thermal energy is added to a solid, the particles in a solid move faster and faster, and the temperature increases. When the particles are moving too fast for attractive forces to hold them tightly together, the solid reaches its melting point. So say for example, when the particles in a liquid are moving so fast that the attractive forces cannot hold them close together, the liquid reaches its boiling point. So by that time, we have our hot pot. Okay? We put water on it for boiling purpose. Okay? So, by the time we start to put fire, burning flame, okay, the concentration of heat started from high or low concentration? Where does the heat coming from? Okay, so it will start from the low concentration to higher concentration, right? Because the heat transfers, scatters on it towards the hot pot or frying pan. So, eventually, after a few minutes, or how long it is, it depends also with the speed of the fire, right? Until it reaches into maximum heat level, more than 50 degrees Celsius and reaches into 100 degrees Celsius of maximum heat temperature. So what will you observe? Okay? By turning liquid into gas in a form of evaporation, water evaporates. Water will evaporate, right? So in this case, there is a gaseous water comes out at the top cover of our hot pot. While boiling the water, after a few minutes, 5 or 10 minutes or 15 minutes, you will see the reaction of water that keeps coming out, in which the gaseous water takes place. So this is by means of evaporation, in which the forces cannot hold them close together, where the liquid reaches its boiling point. Next, we have sublimation. Sublimation, like playing dry ice, occurs when a solid changes directly to a gas without first becoming a liquid. So as thermal energy is added, what is the indicator there? How does the reaction takes place? By turning solid to liquid, turning liquid to gas, turning gas to liquid, turning solid to gas, or turning gas to solid, vice versa. So, in a physical change, as thermal energy is added, as you can see in there, so starting from solid, okay, the temperature gets rising, right? As thermal energy is added to a material temperature, once it increases when state of the material is not changing, temperature stays the same during change of state. So, the temperature keeps rising. When adding thermal energy for heat transfer, okay, solid changes to melting, melting turns to liquid, liquid also but turns into boiling, and of course, okay, producing gaseous vapor, okay, or water vapor. So again, as thermal energy is added to a material, temperature increases when the state of material is not changing. So temperature stays the same during change of state of matter. Okay? So when thermal energy is removed from a gas, particles in a gas move more slowly and the temperature decreases. Okay? So for example, by turning ice into liquid, means to say, this changes of phase of matter from solid to liquid. What happens during condensation? When condensation occurs, when the particles are moving slowly enough for attractive forces to pull the particles close together. Okay? So in condensation, guys, imagine we have clouds formation. Cloud formation that's coming from the source of, okay, those water that's already evaporates from the oceans, the sea water, and the fresh water, like lakes and dams or rivers. So cloud formation, of course, and those clouds will eventually condense as a gas, no? And it becomes heavier or totally, no? The density of the clouds turns into condensation to precipitation point. So the condensation portion will precipitate to become liquid again. So by turning gas into liquid in a form of rainwater. Alright? So condensation occurs when the particles are moving slowly enough for attractive forces to pull the particles close together. So for example of this, no, in condensation and precipitation, okay, turning clouds into heavy or massive rain, okay, from gas to liquid particles. After the gas has completely changed to a liquid, removing more thermal energy from the liquid causes particles move even more slowly. So freezing occurs when the particles are moving so slowly that attracts forces between the particles, hold them tightly together. So what happens during deposition stage? Okay, now what is deposition, guys? Turning gas to solid. Turning gas to solid. Okay? It is a change from a gas directly to a solid. No? Like for example, when we use mothballs. Okay? And also dissolving or evenly mixing a physical change because their identities of the substances involved do not change. How can removing thermal energy affect the state of matter? So removing thermal energy can change the state of matter, a gas to a liquid to a solid, as the particles that make up the substance move more slowly. So the conservation of mass refers to the fact that the total mass before and after a physical change is the same. So this low state of conservation of mass, that the amount of matter, okay, will not be destroyed or nor created. Okay? So, the conservation of mass, okay, the physical change remain constant. Even though you applied another processes or total transformation, but the atoms are not created or destroyed. It will remain the same. Right? So, for example, we mix 5 grams of chemical substance with 150 ml or 150 grams of what we call solutions, no? Or alcohol solutions, sugar solutions. So, therefore, we just only add them with 155 grams or 155 ml of this solution. For example, mixing of 5 ml of sugar with 150 ml of water. So the solutions will become 155 ml of sugar solutions. Okay? So another point to remember, what is meant by conservation of mass? Conservation of mass refers to the total mass before and after a physical change is the same. So, during physical change, matter can change the form, the shape, the size, or state, but the identity of matter does not change at all. Okay? So, this is what a physical change of state of matter all about. Do you have any questions, guys? Do you understand? Okay.